Welcome to another math problem of the week. The floor function and the last digit. Let's talk about it. So for today's question, we are given that the floor of x represents the largest integer less than or equal to x. Example, the floor of 3.14 is 3, the floor of -5.1 is -6, and the floor of 7 is 7. We are asked to find the last digit of the floor of 1 plus square root of 2, the whole thing to the power of 1000. And the options are A, 1, B, 3, C, 5, and D, 9. What do you think?
Pause the video now if you wish to solve it. Keep watching the video once ready.
To solve this question, we need to have two results. Number one, 1 plus square root of 2 to the power of 1000 plus 1 minus square root of 2 to the power of 1000 is an integer. And the second result is 1 minus square root of 2 to the power of 1000 is a very small value which lies in between 0 and 1. We will prove these two results one by one. So first of all, 1 plus square root of 2 to the power of 1000, using binomial theorem, it will be equals to 1 plus 1000 choose 1 times square root of 2 plus 1000 choose 2 times square root of 2 square plus 1000 choose 3 times square root of 2 cube, and so on and so forth until the last term, which will be equals to 1000 choose 1000 times square root of 2 to the power of 1000. Using the similar argument, then we know that 1 minus square root of 2 to the power of 1000, it will be equal to 1 minus 1000 choose 1 times square root of 2 plus 1000 choose 2 times square root of 2 square minus 1000 choose 3 square root of 2 power 3 until the last term, which should be a positive value, that is 1000 choose 1000 times square root of 2 to the power of 1000. Now we should add up the two equations here. In the left hand side, we should have 1 plus square root of 2 to the power of 1000 plus 1 minus square root of 2 to the power of 1000, which equals to a double of 1 plus 1000 choose 2 square root of 2 square plus 1000 choose 4 square root of 2 to the power of 4, and so on and so forth until the last term, it should be a square root of 2 to the power of 1000. And we know that each of these terms is an integer, and not only that, it is a multiple of 10, it is a multiple of 10 until the second last term before square root of 2 to the power of 1000. This means that this is congruent to 2 1 plus square root of 2 to the power of 1000 mod 10. And this can be further simplified as 2 1 plus 2 to the power of 500 mod 10. And we know that 2 to the power 1 is congruent to 2 mod 10, 2 to the power 2 is congruent to 4 mod 10, 2 to the power 3 is congruent to 8 mod 10, and 2 to the power 4 is congruent to 6 mod 10, and 2 to the power 5 will be congruent to 2 mod 10. And the thing will keep repeating. In general, 2 to the power of 4n plus k, it will be congruent to 2 to the power of k mod 10 if n and k are positive integer. From what we have just now, we need to find out what happened to 2 to the power of 500. 2 to the power of 500, it is congruent to 2 to the power of 4, which is congruent to 6 mod 10. So now we know that for this expression, it will congruent to 2 1 plus 6, and therefore this will be congruent to 4 mod 10. Okay, so now we have shown that the first result, it is an positive integer and the last digit is 4. Next, we need another result which saying that 1 minus square root of 2 to the power of 1000 is a value lies in between 0 and 1. To show this, first we know that square root of 2 minus 1, it is in between 0 and 1. In fact, square root of 2 is about 1.414, so minus 1, it will be about 0.414. As such, square root of 2 minus 1 to the power of 1000 will also in between 0 and 1. So combine whatever we have just now, square root of 2 plus 1 to the power of 1000 plus square root of 2 minus 1 to the power of 1000 is congruent to 4 mod 10, and therefore the last digit of this value will be equals to 3. So the answer for this question will be equals to B. And for now, let's look at other people's solution. That's all for today's lesson. I'll see you again next Tuesday. Bye bye.